Bismillah Rahman Rahim. Welcome back to this fifth, I think, tutorial on STM32 programming for beginners. And in this part of this series, we are talking about the GPIO pins. Earlier in the earlier demonstrations, we have seen some theoretical aspects of the GPIO port of STM32. Not in very detail, but an overall cursory information about the port and its pins and how to configure them. In this part, we will be talking more about the GPIO pins and how to program them. Uh, just for the sake of completeness, I would like to talk a little bit about the basics of the bit masking, etc., because these are extensively used in microcontroller programming, and it is useful to have this knowledge beforehand so that there is no confusion later on. So let's talk first about a little bit about the bit masking thing. In bit masking, when we want to set the bits of some registers or to clear the bits of some registers, we need a bit mask to make some logical operations so that we can set or reset certain bits. So in order to make these bits, let's say if we have this 8-bit number, in STM32 you have usually 16-bit or 32-bit numbers. If we want to set the bit number 1, first the 0th bit of the number, we put it 1 here, and this becomes a decimal number 1. And if we want this bit to be set and all other bits are 0, this number becomes 2. Then if this second bit is to be turned on and all other bits are 0, this becomes number 4, 8, 16, 32, and so on. So in the entire word of 8-bit or 16-bit or 32-bit, whatever is the mask you want, you have to set only one particular bit as logic 1, and that bit will be used as a mask. This is because in microcontrollers you cannot set individual bits directly. The process is that the microcontroller performs the operation on the entire word. It not even byte. It performs the operation on entire word. The word in 8-bit computers is 8-bit. It is 1 byte. In 16-bit computers, it's 2 bytes, and in 32-bit processors, it is 4 bytes. So your microcontroller will be performing the operation on the entire 32-bit word. So it is not possible directly to address the single bit of the 32-bit registers. Uh, so we need this some logical operations to set the individual bits. You can combine the masks, like if you want to combine the bit 2, bit 4, and bit 7 in a one mask, you can just OR them together, and the resulting number will have the respective bit set, and all other bits will be 0. This is important because when we want to perform multiple bits in one operation, either we make the mask directly or we can just make these different masks into one uh, number. Then there is another concept which is used to make the masks. Mask is bit shifting. In bit shifting, if you take a standard number as number 1, which is the in which the 0th bit of of this word is logic 1, and if you shift it by 0 bits, nothing is shifted and it remains there. If you shift it by 1, this bit is shifted to this position and the padding is is filled with zeros. If you shift by 2, this number will be shifted 2 bits here. This bit will become 1 and the other bits will be padded with the 0. So in this way, you can produce any number as 1 by 1 shift left to the n, means n is any number that you want to shift. So that will be easier to make the mask. So to facilitate the STM32 programming, the STM microelectronics have produced a HAL library, which is hardware abstraction layer library for a number of peripherals that are present in the microcontroller. So you can use this library to control the pins. Like that, there is a command called HAL underscore GPIO underscore write pin. So this function will accept one uh, port name. This is GPIO A, the pin number GPIO pin 8, and the logic 0 or logic 1 like GPIO pin set or GPIO pin reset. So this will set or reset the pins. So let's uh, come back to our actual programming. So now let's start the IDE. Before that, we have written simple program to use these uh, GPIO pins. So this time we will be starting a new one. But in this discussion, we will be little more talking about the core process which we are uh, doing to. Right, let's clear it and let's start a new STM32 project. So now let's choose the microcontroller STM32F103C8 C8T6, which is the microcontroller we are using in our simulation as well as which is present in our blue pill board. And we name the project as number 1 GPIO. Next, always select this copy only the necessary library files. So this will copy only the HAL library files for the GPIO because we are using only the GPIO in this. Well, next thing which comes is this GPIO, sorry, CubeMX uh, graphical interface to configure the microcontroller. You can do all these things in programming, but it is always more user friendly to configure it on the this graphical interface. So here is your microcontroller with all its pins mentioned. All the pins which are grayed out are called in the reset state. This is the state in which the pins will be in the reset state. And these pins, as I have already told you, these are for power supply pins, so these cannot be configured. This is reset pin, which is also not configurable, but it can be also be used as some functions. So in our simulation, we have PA0 to PA9 connected to LEDs. So we will configure all these as output pins. So just connect or press on PA0 and these are the various possible outputs settings. So we select GPIO output. So see it becomes green, means it has been assigned as GPIO output. So next we set this again GPIO output, this as GPIO output, PA3 as GPIO output. So this is up to PA7. So PA8 is here. Although the pins are grouped together conceptually, but physically they are not grouped together. Oh, PA9 we are not going to use. PA10. So it is up to PA9. PA0 to PA9, these are the 10 pins which we'll be using. Other settings of individual pin that you can perform is you can just go to this core and here is the GPIO. Now here you can see that all the GPIO pins have been mentioned here. So PA0, if you click here, the various settings of this pin appear here. So initial output state is low. The pin IO mode is push pull or open drain, as we have discussed in the last discussion, that there are possibilities of using it as push pull or open drain. In open drain, the pin can only assume a zero state by sinking the current, but it cannot take the logic 1 by providing 5 volts. But if you use push pull, the pin can assume both 5 volts as high and 0 volts as low. Then you do not want to use pull up or pull down resistors because in input mode we use these as pins, these mode. The maximum output speed. This is the speed on which this pin can be configured as from 0 to 1 and 1 to 0. So the higher the speed, the higher will be the performance of your IO port, but it will also consume more current. So you have to choose it this speed according to your requirements of your project. So in our case, we do not need very high speed. Use it just this low. You can also give it a label as like LED 0, LED 1, LED 2, and these are user friendly names. So let's give it a name at LED 0. And you can see here also the label has been changed to LED 0. Similarly, you can set for all the other pins of this uh, GPIO that you have selected. Right, we can close it by pushing this. Then I just want to mention a little bit about the clock configuration. The clock configuration right now is that we are using 8 megahertz internal oscillator and 40 kilohertz internal oscillator, which will be used for real-time clock, which we are not going to use right now. So you can see in this graphical interface, this is the pathway of your 8 megahertz clock to your all the peripherals that are linked to it. So you can see this 8 megahertz clock is going here and without any multiplication or without any modification, it is going as 8 megahertz system clock. The advanced high-speed bus prescaler is divided by 1, so the high-speed clock is 8 megahertz. If you divide it by 2, the high-speed clock will become 4 megahertz, and all the other peripherals will also get 4 megahertz speed. So it depends how much speed you want to give and how much speed you want to take. Remember, the more speed, that means more power consumption, and that means lower battery life. So because these STM32 series of microcontrollers, they are meant for power saving applications, so they have got a lot of options to save the power. Even you can change the power speed of individual buses, and as you know, these different buses, they actually power the different peripherals. So just for For this demonstration, we just keep all these things as standard. So now let's generate the code. So the code has been generated, and we have this now main file with a number of comments on it. You can remove these comments, but if you want to reconfigure these pins on this uh, graphical interface, then it will have difficulty to identify which code was generated by the auto code generator, and it may overwrite your code. So it is better to respect these uh, comments. So here is your main function, and here is the function which is going to call the initialize the HAL libraries. And this is the function which is going to configure the clock settings which were selected in the uh, GPIO in CubeMX graphical interface. Right, and here is your endless loop in which your user code will go. So we start our user code from here, from here. Right. So we want to toggle the first LED on and off, just like the Hello World program that we did before. So just write HAL, that is Hardware Abstraction Library, underscore GPIO underscore. And if you want to get the help from the IntelliSense, just press Control and space, and all the possible GPIO, HAL GPIO commands will pop up. So you can use here GPIO write pin. So GPIO write pin, and it has filled up with all the standard uh, prototypes here. So you will just replace these with your required ones. So first is the GPIO X, means the GPIO port. So you will write here GPIO A, and then you will write the pin. So GPIO underscore pin, and again we want to get the help from the compiler. Just press Control space, and this is GPIO pin 0, and then state GPIO pin control space pin state set. That means it will become logic 1. Now, the objective of showing you the bit masking was because this number GPIO pin number is actually the bit mask. See, this is the number 0x0001, which is hexadecimal 1 number. If I change it to pin number 1, and the mask changes to 0x0002. So just by these masks, these numbers have been written by the HAL library people to facilitate us, so that it is easier for us to remember or understand. If you want to see the details of this, just point on it, press the right button, and go to open declaration. Now here are the declarations. This is the STM32 F1 HAL GPIO HLab file, which contains all the definitions for these pins. GPIO pin 0 is defined as 0x00001. This is 32-bit number. Then this is pin number 1 is 0x0002. Then pin number 2 is 0x004. So see, these are the same numbers which we discussed in our presentation here. These are the same numbers. These numbers are given in decimal, and there the numbers are given in hexadecimal. So you can use these numbers directly, or you can use these defined definitions, which make it easier to see and understand, right? Similarly, is this uh, GPIO pin set. As you can see, it has been defined as logic 1. If we change it to reset, sorry, pin reset, then this number is logic 0. So we can write either here the pin mask or the similarly as logic 0 and logic 1, it will be the same thing. So if we run this program, it will turn the LED pin number 1 as high. So let's first go to compile it, build project. So there are no errors and no warnings. As you can see, this project will be producing uh, a file. Uh, this is our folder, and this is debug, and it has produced GPIO.elf file, which is the compiled file which can be uploaded into your microcontroller. But in to run this program in your simulator, we need hex file. So hex file is not generated by default. So to generate the hex file, we have to configure it. Just go to the GPIO project and go to the properties. In properties, go to C and C++ builder, go to settings, go to MCU post build outputs, and here select the convert the hex file to convert to hex file. Apply and close, and now re pro, uh, build the project. So if we see the folder now we have got the hex file. So this hex file will be running on your simulation. So if we come here and we choose the hex file from our project, one GPIO, debug, and GPIO hex. Open and OK. Now let's run the simulation, and it should have produced this result. Sorry, it was set to reset. We have to change it to set position, because when we will set it, only then the output will appear. Project, build project, and run it again. So you can see this pin number 0 has been turned high. Now what if we want to turn the two pins high, like GPIO pin number 0 and 1, both we need to turn high. So we can just OR them together. This is the symbol of OR, and GPIO underscore pin 0. It does not matter whether you mention it first or whether you mention it last. It does not matter. When we will OR them together, the number 0x001 and number 0x002 will get odd, and a new mask will be formed in which both pins will be high. So let's build it and see, run it. So now both of these are high. So now let's say if we want to turn both these and pin number P and 9 also high. All others will be 0 and only these three want to be high. So let's stop it and go back to IDE, and also OR GPIO underscore pin number 9 project build you can also build project from here, or you can also build project by clicking on here and build the projects. These are the same thing. And now you run it, and you can see all the required pins are simultaneously turned as 1. You can do them individually as well if you want. Let's stop it. For that, you will have to write the function 3 times. Like if you want to comment this line, either you can press two double uh, slashes to comment it, or just press control and forward slash, and this will comment the entire line. So let's write the function again. HAL underscore GPIO underscore write, control space, and GPIO A, and in pin we mention uh, GPIO underscore pin 0 and GPIO underscore pin set. So just copy this line, control C, and paste it 3 times. Change this to pin number 1 and change this to pin number 9. So it will be doing the same thing as this single line, but this time we are calling the function 3 times. Project, build project, and sorry, our simulation has some problem. So let's call it back. Just to see if you have to change it. GPIO debug and GPIO X. Let's save it so that we don't have to write it again. And again, you can see it is the same effect, that these two pins and this pin are logic 1. So combining them together in one go, or combine using them as individual pins, is the same thing. This is more better approach because it does all the settings in one go. Here the function will be called 3 times, and number of cycles of the processor will be taken separately. Now I would like to show you that if we want to use just the pin number, like the mask which we mentioned, is if you just write 1 here and 2 here and and its mask will be pin number 9. Mask uh, will be something different. I don't remember. Anyway, its mask is 0x200. So this is number 200, 0x 200. So if you place 0x before a number, it becomes hexadecimal number. Here the number is only digital number because 1 and 2 decimal and hexadecimal are same. So if you build it, it should produce also the same result. See, same result. So basically, the microcontrollers are all about these numbers. So you have to give only the number, but because we humans are not good in remembering the numbers, it is good to remember the symbols. So that's why we give these pins symbols GPIO underscore pin 0 and GPIO underscore pin 1 and GPIO underscore pin 9. Another thing that I want to mention is because we had labeled that I don't know why it is not coming properly. If you go to this, we had labeled it as LED 0. So we can use, instead of using the PA 0 or the pin 0, we can use only this LED 0 symbol as well. So if you just go back, let's generate the code. Although it is not needed, we have not made any changes. So let's comment out this line, control forward slash, and here I want to write a new line again, HAL underscore GPIO control space GPIO underscore HAL underscore GPIO write pin, and here instead of writing the GPIO A, I write LED 0 control space, so LED 0 GPIO port. So it already knows that it is port GPIO port A. This is the address of GPIO port A. And here you can also write LED 0 control space pin. So it already knows which is pin this. This is again 0x001, the same thing which was written here. So if we build this project, it should also produce the same results. So there was no semicolon here. Semicolons are the most common mistakes in C programming. Other mistakes are these missing curly brackets. So this pin state must be changed. GPIO underscore pin set project build project. Now there are no errors, and see, running the program. Again, this pin 0 has been set. So to facilitate the programmers, the IDE or Integrated Development Environment provides tools that helps the programmers. Although you can do all these things by using just numbers, but You can use the predefined symbols, or you can give your own symbols so that when debugging the program, it becomes easier for you to read that which pin I am talking about. I am talking about the pin on which LED 0 is connected. So this makes understanding and reading the program easier. So let's stop here and we will continue with the same program in our next session, talking more about the GPIO outputs. We are just talking about GPIO outputs right now. We are not taking any GPIO input that we will also include in our upcoming discussions. Thank you very much, and I hope you would have enjoyed it. Do give us a thumbs up and subscribe to our channel. And I hope to get you some good stuff uh, as we find some more useful tutorials and lectures for you. Thank you very much. God bless you.